how do you take the derivative of a function like e to the 3x plus 1 or sine of x squared? These are called composite functions, functions inside other functions. And to differentiate them, we use the chain rule. The chain rule says to take the derivative of f of g of x, first take the derivative of the outer function, f, while keeping the inner function, g of x, unchanged. Then multiply by the derivative of the inner function, g of x. To make this more intuitive, let's look at another notation of the chain rule. We want the derivative of y with respect to x. But y is written in terms of u, not x. So when we differentiate y, we get the rate of change with respect to u. Thus, to find the derivative of y with respect to x, we can multiply by the derivative of u with respect to x. Now, you can think of the u terms canceling out, and we get the derivative of y with respect to x. Now, let me explain it this way. Remember that a derivative is the instantaneous rate of change, so it's a rate. So when thinking of the chain rule, think of it like we're multiplying rates together. Think about this. Obviously, 10 miles a minute is not the same as 10 miles per hour. The distance with respect to time is not the same. But if we wanted to change the rate from miles per minute to miles per hour, we know that a minute with respect to an hour is 60 minutes per hour. So if we multiply by this rate, we get 600 miles per hour. And that's really what the chain rule is all about. So now that we know the intuition behind the chain rule, let's use it in a real example. Find the derivative of e to the 3x plus 1. We can break this into two functions. G of x can be 3x plus 1, and f of v can be e to the power of v. So if we set v to g of x, we see that we're looking at a composite function. Now let's use the chain rule. First, let's take the derivative of f evaluated at g. The derivative of e to the v with respect to v is just e to the v. If we set v to g of x, we know that g is 3x plus 1. So e to the power of g is e to the power of 3x plus 1. Alright, now all we need is the derivative of g with respect to x. G of x is 3x plus 1. Since we're adding, we can take the derivatives separately. The derivative of 3x is 3, and the derivative of 1, a constant, is 0. So the derivative of g with respect to x is 3. Now, we can multiply everything together. And to simplify, we can move the 3 to the front, giving us 3e to the power of 3x plus 1, and that's the derivative. Cool. Now, the chain rule also works for even denser functions. Check this out. Let's find the derivative of cosine squared of 5x squared. Okay, let's break this down. First, we notice that the cosine is squared, so we can technically notate it this way as well. The notations mean the exact same thing, but this one makes it easier to identify the functions. Alright, let's break this into three functions. Starting from the inside, let's make h of x 5x squared. And the next function, g of u, can be cosine of u, and our final function can be f of v, or v squared. So the full expression is f of g of h of x, where u is h of x and v is g of u. A function inside a function inside a function. Alright, let's use the chain rule. We want to find the derivative of f with respect to x. However, if we take the derivative of f right away, it will be with respect to its input, which is g, not x. So let's multiply this by the derivative of g with respect to its input, h. Now, we have the derivative of f with respect to h, not quite x. So let's multiply this by the derivative of h with respect to its input, x. Now, we see that the derivative will be with respect to x. Alright, cool. Now, let's take the derivative of f of v with respect to its input. The derivative of v squared with respect to v is 2v. Now, in the actual derivative, f has an input of g of h of x. So let's set v to g of u and u to h of x. Substituting that in, we get 2 times cosine of 5x squared. Now, what is the derivative of g? The derivative of cosine of u with respect to u is negative sine of u. We set u to h of x. So substituting in h of x, this becomes negative sine of 5x squared. And finally, we take the derivative of h with respect to x. Using the power rule, that's 10x. Now, we multiply everything together. And simplified, we get negative 20x times cosine of 5x squared times sine of 5x squared, and that's the derivative. And that's the chain rule. You can see how the chain rule got its name. Technically, you could go on and on and on, and that's what makes the chain rule so cool and so useful. If you found this useful, don't forget to like the video, subscribe, and share it with friends. Now, keep working hard and keep learning. Thank you for watching.